Hey guys, all right, so here's the deal. My computer is currently at 24%, so I'm going to go through this rather quickly so that I can make sure that my computer doesn't die, but we still get this in. Okay, so first off, today we are comparing linear, exponential, and quadratics, okay? So, first off, let's take a look at this core concept to begin with. You guys know the difference, right? All of the different shapes. Linear creates a straight line and it's in the form of y equals mx plus b. Okay, that's a big thing. Exponential has kind of that tail to it, if you want to call it that. And it's in the form of a times b raised to the x. And then quadratics is what we've been working on the last few days. It's ax squared plus bx plus c. So just make sure that you know all of the different shapes that go with them. We're going to take a look at part A. So the first example, tell whether the points appear to represent a linear, an exponential, or a quadratic function. Okay, so it's going to be one of those three. We just have to figure out which one it's going to be. Okay, so first off, we just have to go through and figure out, okay, so I've got, let's see, 4, 4, and then I've got 2, 0, then I've got 0, 0, and then 1, negative 1/2. So really, if we follow the directions and do what they tell us to, it just says plot the points. So clearly I don't have a graph on here, so I'm just going to make a quick graph. So I'm at 4, 4. Okay, so that one's going to be up here. 2, 0, 0, 0. And then I'm at 1, negative 1/2. And then negative 2, 4. Okay, so if I look, that's got just that U shape to it, so it's a quadratic. Okay, good. Example 1. Example 2, or example B. Again, plot the points. You're at 0, 1, 2, 4, 4, 7. Okay, so about up here, negative 2, negative 2, and then negative 4, negative 5. Okay, so to me, that's pretty linear. So that example is going to be linear. And then you've probably already guessed what letter C is going to be, but let's just go ahead and prove it. So I'm at 0, 2. Oopsies. So 0, 2. That's up here. 2, 8. Okay, so that's going to be somewhere up here. And then, God darn it. Okay. And then we've got 1, 4. And then I've got negative 1, 1. And then negative 2, 1/2. Okay. So just kind of following that general trend line, this is going to be in that exponential form. Okay. All right. Quick and easy. Let's take a look at the next core concept. Pause the video. Make sure that you get these 3 statements written down. I'm not going to spend a ton of time on them, but they're important. You're going to need to make sure you have them in your notes. Okay? For a linear function, first differences are constant. For exponential function, you have a common ratio, which means that you are multiplying by the exact same number every single time. Quadratic function, your second differences are constant. Okay? So let's take a look at example A. And then once we go through these few examples, really we should be close to done. All right, so tell whether they represent a linear, exponential, or quadratic again. So what we're going to start off by doing is in our y values, we're going to figure out what are we going up by, down by, whatever. So here I'm going down by 3 from 8 to 5. Again, I'm going down by 3, down by 3, down by 3. Okay, so this means that the first differences are the same, which means that you've got a linear. Okay, I'm going to take this one step further and I'm going to say, okay, well, since it's a linear, what is the equation of that linear? So if we go ahead, we are in the form of y equals mx plus b. Figure out what our slope is. Okay, we're going up by 1 each time here. And then we're going down by 3. So remember, your slope is rise over run or change in y over the change in x. Okay, so we're probably going to be doing the change in y over change in x here. So that would be negative 3 over 1. So our slope is going to be negative 3. And then our y-intercept, remember, we're trying to figure out where x is 0. That'd be negative 3x plus 2. Again, that's a big review question. So hopefully you guys are able to get that one even without my full explanation. Here for letter B, to get from here to here, and here to here, and here to here, here to here, notice that we are multiplying. We've got a common ratio for each of these. We're multiplying by 2 each time. So again, we've got an exponential. And with that exponential, that needs to be in the form of y equals a times b raised to the x. Okay, so our a, you guys, is basically just, again, where that's crossing. So that a would be 4. B is that common ratio, which we just figured out as 2. And then that's going to be raised to the power x. Okay, then lastly, here, let's see, I'm going down 1, and then I'm going up 1, then I'm going up 3, and then I'm going up 4, okay? So these first differences are not the same, but here's what they mean with a quadratic by second differences being the same. So to get from negative 1 to 1, you're going up by 2. From 1 to 3, you're going up by 2. And then from, let's see, sorry, this should be a 5, my bad. And then from 3 to 5, again, you're going up by 2. Okay, so since these second differences are the same, then we know we've got a quadratic. Okay, so there's that quadratic. Let's quickly see if we can come up with the formula. So here's what we're going to be doing. I would say let's use that a times x minus h squared plus k. Let's use our vertex form because we've got our vertex. As you guys notice, from this point, this stuff starts reflecting. So this is going to be our vertex. Okay, so let's go ahead. Let's throw that in there. So that's x minus, or except, shoot, it should be x plus 1. And then minus 2. Let's go ahead. Let's use any other point in this table. Doesn't matter. I will just, for the sake of this example, use this one because 0 is a super easy number to plug in. So I'm going to plug negative 1 in for y. I'm going to solve for x. Or sorry, for a. I'm going to plug 0 in for x. And then if I just quickly solve, 1 squared is just 1. So then that would be a minus 2. So then a is going to turn out to be 1. Okay, great. So that didn't change a whole lot. But then our formula then is going to turn out to be, so I'll just write this in a different color. It should be y equals, your a value is 1. That'd be x plus 1 squared, and then minus 2. Wait a second. Except did I just do that wrong? Oh, I see what I did. I didn't do anything wrong, but what they might ask you for is to put it in standard form. So if you take this from the form that it's in, x plus 1, so that'll turn out to be x squared plus 2x plus 1, and then that'll be minus 2. So then that would be y equals x squared. I don't know why that's not working. X squared, and then plus 2x, and then minus 1. Okay. let's see, this would just be, that's not the example that you guys have. This is the example that you guys have. Again, it's really similar to the last few examples that we've done. Then write the function as the added piece. Okay? So again, if you take and you figure out, okay, where's that vertex? Where are things starting to reflect? That's kind of in this range right here, because now you're getting back to 0 and then you're getting back to 12. So let's use y equals a, x minus h, and then, except let's not use h, let's use p, and then y, x minus q. And if you notice, you guys, with these are those vertices. So that would be x minus 4 and then x minus 8. Again, you want to go through, you want to figure out what your a value is, so pick any other point there. Let's just use, let's see, what number did I use? Oh, I just used this vertex here. So I plugged -4 in here. I solved for a, so 6 minus 4, and then 6 minus 8. So -4 equals 6 minus 4 is 2 times -2. So again, that would be -4a. A would just be 1. And then I just went ahead and plugged all of my stuff back in. So y equals, your a value is 1, so that would be x minus 4 times x minus 8. FOIL all of that together. So that would give you x squared. Let's see, that'd be minus 12, and then that'd be plus 32. Okay, so sorry if this went a little fast. I was honestly just trying to get this in before my computer died. But if you've got questions, feel free to email me. Otherwise, I will see you guys soon.